one joined today, so I think I'll record the video and I'll upload. Maybe due to the Holi, a student not joined today. I'll wait 2-3 minutes more, then I'll record the video. Others, I am audible?
Yes, sir, audible.
Okay, fine. Okay, let us start with the first question is the, let me just read. The major head loss in turbulent flow, let me just take the pen. Yes, the major head loss in turbulent flow in pipe varies directly as velocity, inversely as a square of the velocity, inversely as a square of diameter, approximately as the square of velocity. So you have 4 options. So you can reply in the chat box. You can reply your answer in the chat box. The major head loss. Here the question is talking about major head loss in case of turbulent flow. Okay, you are telling D. Yes, okay. Let me just discuss. So here head loss formula is FL V square by 2ZD. Or you can say 4. This is your friction factor. This F is related with the friction of your maybe pipe or any duct. So, but here we are only interested with velocity because the term is given velocity and diameter. So diameter here is inversely a square of diameter not. This is not correct. So again, directly as velocity, inversely as a square of velocity not, directly as velocity, directly as a square of velocity. Here you can see inversely as a square of velocity not, approximately as a square of velocity. Yes. Approximately as the square of velocity, approximately directly proportional to, maybe here term should be there. I think, let me just check the correct answer. Okay, so here the HF is your directly proportional to, here is approximately written, approximately directly proportional to as a square of velocity, it should be there, directly proportional to your V square. So this is the correct option for this question. Question number 1, the major head loss in turbulent flow. One thing here is important. In case of turbulent flow and laminar flow, in both cases for calculating the major head loss, we will use the same formula. HF is equal to FL. Actually here is, if the friction factor is given, let us suppose this is a friction coefficient. The friction factor is 4F by friction coefficient. Let me write here C. So this
Fanning
X
coefficient.
you can replace with the F LV square by 2ZD, or small d or capital D. D here is the diameter of pipe. Yes, so here in case of laminar as well as in turbulent, we use the same formula for calculating the measure head loss, but the F, the calculation of F is different for laminar, for turbulent. In case of laminar, we use actually 64 by Re, and in case of turbulent flow, here is laminar. In case of turbulent flow, we actually calculate by using the uh, one, or you can say the Moody's diagram. Moody diagram. The Moody diagram is based on one equation, which is okay. I'll tell in the later slides. Now let's move on the next question. Next question is the hydraulic mean depth for a circular pipe of diameter d is given by. The question number 2. The question number 2 is the hydraulic mean depth for a circular pipe of diameter d is given by 2d, d by 2, option C, d by 3, and option D, d by 4. Yes, others were telling yes, this formula will use for both laminar as well as turbulent. Though your second question, why approximately? Yes, it is directly, and the fanning friction coefficient. Yes, good. Now your for question number 2, you are telling B option or 2D. Okay, what you are writing here? 2D is A option, or finally I think you are telling the B option. Okay. And Abdul is telling D, option D. Other student, please also, Anurag, you can also tell your answer for this. The hydraulic mean depth for a circular pipe of diameter D. Here, actually, question is asking about hydraulic mean depth, not about the hydraulic diameter or hydraulic radius. Here we are, question is asking about only depth, mean depth. So hydraulic mean diameter or hydraulic mean or hydraulic diameter is the same. Okay, just I'll tell. Okay. Okay, let me discuss. So the question here, the hydraulic mean depth. So the others is asking about the hydraulic diameter, hydraulic mean diameter. The A by P, weighted area by weighted perimeter. Hyd hydraulic depth or hydraulic mean depth, hydraulic diameter, I think you are asking. Let me just see your question. Yes, hydraulic diameter, yes. But here the question is asking about the for hydraulic diameter, mean diameter, and hydraulic diameter is your this sorry, hydraulic radius actually, hydraulic radius or hydraulic mean radius is AW by P, but here hydraulic diameter is 4 AW by P, remember. So here question is asking about mean depth, hydraulic mean depth. So hydraulic, what is hydraulic mean depth? So here formula is for hydraulic mean depth. Hydraulic mean depth is A by P. So hydraulic mean depth here is A by P, means your pi by 4 d square, or the same formula for hydraulic mean radius. Hydraulic mean radius is same as your hydraulic mean depth. But here question, but hydraulic diameter is different, 4 AW by P, remember. So A by P, pi by 4 d square divided by your perimeter is pi d. So you will get pi by d by 4. The correct answer is D. The next question, the discharge in laminar flow through pipe varies. The discharge in laminar flow through pipe varies inversely as pressure drop, directly with viscosity, inversely with viscosity, as the square of radius. The discharge in laminar flow through pipe. So actually here you have to recall one more relation between your here pressure drop, radius, viscosity and discharge. Then you can uh, correct the answer. Okay, you are telling option D as a square of radius. Okay, other student please also try. So I'll wait 1 minute. Okay, let me discuss. The formula for your discharge and the relation of your viscosity and pressure drop and radius is Q is equal to, for pipe flow, Q is equal to pi by 8 mu change in pressure, that is your pressure gradient, R square, R to the power 4, not square. So this is the formula. So here your Q is inversely proportional to viscosity, as the square of radius naught, that is the 4 times. But here the correct answer, if you compare your Q with dynamic viscosity mu, so it will give you C option. The option C will be correct, inversely with viscosity. The next question is, here is, in laminar flow through pipe, the Reynolds number, option A Reynolds number less than 2000, Option B, Reynolds number greater than 4000. Option C, fluid particle move in zigzag manner. None of the above. In laminar flow through pipe, what should be the correct answer for question number 4? Okay, everyone telling the option A correct. Yes, this is a very simple question. Just please for pipe flow, just I want to ask here, just I want to add the laminar, that is your Reynolds number in case of laminar pipe flow. Laminar, not pipe, open channel. What should be the range? Or just let me write here, less than equal to dot dot dot. What should I fill here? In case of open channel. Okay, you are telling from continuity equation we can write Q is equal to pi r square V. So it should be also, you are telling, but why? Okay, the option is well, Abdul is telling 500. Yes. So you are telling here you can write the formula Q is equal to, if this is pipe, and if section 1, section 2, Q1 and Q2, so it will be equal, Q1 is equal to Q2, and you can write Q is equal to AV, or here A1 V1, right? And area is equal to pi by 4. Let me just, okay. So here pi by 4 d square and V, or pi r square you can also write V. So from here you are telling as a square of. So I think here term is missing as the directly proportional to r square. I think due to this reason option D is not correct. Maybe. But if you look all three options, so you need one relation with which have the pressure drop, the discharge have the relation with pressure drop, viscosity. So this is relation between your viscosity and pressure drop. From here you can write your discharge is directly proportional to your r square, directly proportional to. So I think here one term is missing, that's why D option is not correct. So yes, 500 here. Fine. Now we'll move on the next question. Next question is, the velocity distribution for a steady laminar flow in pipe, exponential, parabolic, linear, or none of the above. The velocity distribution for a steady the velocity distribution for a steady laminar flow in pipe. So here actually you need to tell about the distribution profile of velocity in case of laminar in pipe. So you all please try to give the answer for question number 5. B, parabolic. Okay. Other student, please also try to give your answer. Okay, for fully developed, yes, parabolic. Okay, I'll discuss a little bit about your fully developed flow. So before I need the answer from all participants side. The velocity distribution for steady laminar flow in pipe. So within 1 minute, please try to give your answer. Otherwise, I'll discuss. After 1 minute, I'll discuss. Okay, let me discuss. So in case of your laminar flow, so let us suppose pipe. This is your pipe, and water is entering with your uniform velocity here. Uniform velocity means everywhere velocity is same. But after entering in the pipe, what will happen due to the no slip condition or due to your viscosity? The velocity at the wall will be zero. Here your velocity will be zero. Little bit here velocity is zero. Here is little bit more, little bit more, little bit more. From this side also 0, 0, 0. So as let us suppose here is 0, here is 0, here let us suppose 1. The magnitude is 1. Here the second point is magnitude is 1. Just for example. As you move in forward direction, this side, what will happen? This the velocity of magnitude 1 will be, that is here the concept will come the boundary layer. Remember please. The concept here will arises the boundary layer due to this wall like that. As you all know, the effect of wall will be increase. Effect of wall will be increase in x direction. The effect of wall, this wall, as the mass, that is the here is, let us suppose at this section, the if you consider the mass will be very very less. Here mass will be very very less, but when you will reach at this position, the mass is high. So it means mass is high. That means the effect of your wall or effect of your no slip condition will be apply on large mass compared to the first one, large mass. That's why this the variation of your boundary will be increased in x direction. If this is x direction, in the flowing direction. So here is this much, this much, this much. That is, as the mass is entering, more and more mass is entering in the pipe, what will happen? The effect of your wall will propagate more because of the mass. The the mm, many particle interact with your wall, and wall try to reduce the velocity. Yes, like that. Oh, sorry. So your velocity, the boundary layer will form like that. So your velocity distribution here, let us suppose, just, so your velocity distribution will be here. Up to that much your velocity will be vary from this side this will be same, but just for drawing purpose, not correct. Here will be the constant, remember please. Here also like that, the vary up to this much, here is vary up to this much, and this will be constant, remember. So similarly here, and from here up to this point the velocity is vary up to here. From this side also velocity is vary like that. There is nothing constant point like that, nothing constant line actually. So after that your velocity will be, we have like the same diagram, the same parabolic. This is the parabolic if the flow is laminar. But in case of turbulent, what will happen? In case of turbulent, let me just draw. If the, let us assume this is the laminar flow, but water is entering turbulent, remember. So what will happen after fully developed? After fully developed, the velocity diagram will be, it will be straight here, linear variation, here also linear variation, then logarithmic variation. So the very logarithmic variation portion is much more than your linear. So generally we call the turbulent velocity variation is logarithmic because of the portion is much compared to your linear variation. So remember please. So hope you all got it, my point about the, okay. No, fully developed flow means you are telling equal to the steady flow as per others is telling. No, not a steady. Just for condition is given here a study. Okay. So now we'll move on the next question. The next question is, so here you can see the expression parabolic variation. U is equal to minus 1 by 4 mu del P by, that is pressure intensity, R square minus. Now we'll move on the next question, question number 6. The ratio of maximum velocity to average velocity in laminar flow through a pipe. The ratio of maximum velocity U max to U average in laminar flow. Remember the condition also given, laminar flow or pipe, the flow through pipe. The four things here is given. Remember, and the ratio, just please try to give your answer for this question. So pipe means here circular pipe, remember. So negative here just showing you the pressure drop as you will move in the flow direction, just the pressure value will be reduced, so that's why negative is written here. Okay, D option Anurag is telling for question number 6. Okay, others is also telling D option. Okay, for duct all you are telling 2 by 3. Okay. So here actually I have one very interesting slides. Why we use generally the circular pipe rather than another shape in case of flow, liquid flow or fluid flow. So there are many reasons. So just I'll show you why we generally use the your circular pipe rather than another. Okay, anyone want to tell the answer of this question? Yes, this is one of the reason, but another reason also I'll just show you. Please, other student, please also try to give your answer for question number 6. Very easy question. Sometimes very frequently this question is asked about some competitive exam also. Many times asked. Okay. So yes, answer 2 is correct for question number 6. Okay, here one question is also important. Let us assume the flow between flat plate. So here U max by U average, how much? In case of pipe, you have the maximum velocity U max divided by U average is equal to 2. Means the maximum velocity means this velocity U max. This maximum velocity is 2 times your average. But in case of flat pipe, that is the flat plate, the U maximum and U average ratio. The average means what is average? So just if I draw the same thing, but here is variation is parabolic because the laminar pipe flow. Here is the uniform flow means the average flow means what? Average velocity means everywhere velocity will be average. Here velocity is different. If you are assuming the axis like that, this is velocity axis and this is your depth axis. Let us assume y. So just here you can see if I draw the axis here, here is velocity and this is your y, or you can say the depth. So as you can see the velocity here is different, the velocity here is different, the velocity is changing, but average means what? Everywhere velocity will be same, like that everywhere. everywhere velocity will be same. Everywhere velocity will be same. This is the meaning of average. So the ratio when you will calculate, it will come 2. So let me just see the answer here, if anyone. Okay, so you are asking about NPTEL questions will come in the GATE exam. So it might be not directly come, but you can just think some important questions, the concept based questions may come. Yeah, some questions are very important in your assignment. Actually, the assignment question level is very low compared to your GATE exam. But uh, some questions in your assignment is at the level of GATE. So you can expect the concept in GATE exam, not the direct question. So you max by, okay. So you are telling, others is telling 3 by 2. You max by, okay. Other student, please also want to tell. So remember please, in case of flat pipe, the value will be 1.5. Always remember. The next question. So here you can see U max value and U average value. What were the above formula? If you will see this one, this formula. U is equal to the velocity variation 1 by 4 mu del P by del X R square minus R square, small r square. So from here you can calculate this value U maximum. So U maximum you know already, at the, if your R is varying, R is radius, that is R is this direction. So if R will be 0, small r will be 0, what will happen? You will get the maximum velocity. Means U is equal to U max at R is equal to 0. Means 1 by 4 mu del P by del X. R square will be 0, so only R square will be remain. Just you can see here. Now, the average value, after averaging, that is after averaging this curve, you will get average 1 minus 1 by 8 mu del P by del X R square, and after ratio will get 2. Now we'll move on the next question. Next question is question number 7. Yes, important question. At what radius from center of the pipe of radius R the average velocity occur? Means the question is, option D will be none of the above. The question is, if this is pipe, assume with radius, the radius R, and the variation in radius direction is small r, right? That is, and this is your midline of the pipe, and this is your velocity variation. The actual velocity variation is this laminar flow if the actual velocity variation is this. But after averaging this this value will be like that. Let us suppose after averaging you get the here line, So this much. Here you just touch this profile, just you touch by arrow this one at the at that point. At that point you just touch. So you need to calculate this value in this question. At what point your average value just touch your parabolic profile. So this is the question. Now just you can think. Option A you are telling R is equal to R by root 2. Okay. The meaning of question is this, what I discussed. So other student, please also try to give your answer for question number 7. These questions will help you a lot in your GATE exam. So, but if you are targeting GATE, so you need to solve previous year question, fluid mechanics previous year question, not only fluid mechanics, all subjects, previous year at least 10-year questions, at least last 10 year, or if possible as much as possible, at least 3 to 4 times, 5 times you just try the same question, then you will get very clear. Or sometimes the concept repeat in the GATE exam, so you can very easily solve the questions, but you have to have more practice. If you have the lot of practice about 4 to 5 times for last 10 year or 15 years questions, so easily you can get 50 marks in the GATE exam or more than 50 marks, but you have to 4 to 5 times revision for same questions. The questions designed like that, so you can definitely get the 50% marks. Okay, so no one. Okay, let me just discuss. So here is the, I think, question, you all got it. So let me just show you the calculation part. Here just you can see the the profile for your parabolic profile, like this profile, you have this equation. For average, you have this expression 1 by 8 mu del p by del x r square. The question is at what point your these two value will be equal. The question is in different way, but what I have explained, just you can see, just let me just focus. At what radius from the center of the pipe of the radius r the average velocity occur, means at what point your average velocity will be equal to your parabolic profile velocity. So it means the equal. the average velocity and whatever you have parabolic profile velocity will be same at what point. The question is this from the center line. So just you can write here. So 1 by 4 mu del p by del x r square is equal to average velocity 1 by 8 mu del p by del x r square. So here mu will be cancel out and this minus minus not cancel out, just you can see when you will arrange that will be cancel out. So like that, so only here is and 4 to the 8, so here is r square minus r square is equal to 1 by or r square by 2 you can say, means 2r square capital R square minus 2 small r square is equal to r square, means r square is equal to 2r square. So here you need to calculate the relation between small r to capital R. So small r is equal to r square by 2. So from here you can write very easily the square root, not square root, that is r square divided by is power 1 by 2 here, and power 1 by 2 means what? Root. So this 2 will be cancel out, so r is equal to capital R, and 2 to the power 1 by 2 means root r, small r. So not r, this is 2. So hope you got it. Now we'll move on the next question. This is important question, please remember. The question 8. The maximum velocity in circular pipe when the flow is laminar occur at top of the pipe, bottom of the pipe, center of the pipe, none of the above. Very easy question. So everyone please just try to give your answer. C. So basically in mathematics you have to just the matrix you can very easily you can get 2 marks from your matrix question, eigenvalue, eigenvector, or sometimes rank question, or sometimes some properties, orthogonal, like that. So you can get easily 2 marks from your matrix section, and you have to know how to calculate the maxima, minima, little bit your order and degree of differential equation. That's it. Or just try to solve only previous year question in mathematics. Just go through one syllabus and just try to solve the previous year question. That's it if you are poor. So definitely out of 10, maybe if the question, it may be 15 marks for your mathematics from mathematics part. So you can get very easily 5 to 8 marks. Just if you have the revision of your previous year mathematics question. Okay, Abdul is telling C, everyone telling C, yes. From the last maybe 3-4 questions I have discussed these things only. The maximum velocity, the center of the pipe, yes, good. So now I'll take 5-minute break. So if you want, please you can also take. So here just I want to show you the next question. So just try to solve, or you can also take 5-minute break here. Okay, I'll discuss the question number 9 after break. So, Okay, the question number 9 is the shear stress distribution in the pipe flow is given by the shear stress distribution, please. How shear stress varies with pipe, varies in pipe actually. So option A, tau is equal to minus your pressure intensity by R by 2. Tau is equal to R del P by del X, and tau is equal to minus 2R del P by del X. None of the above. Which option will be correct? So the Anurag, oh, others is telling option A. Okay. For previous questions, I think Anurag is telling C. Okay. For previous questions, all Abdul, Anurag, and others telling C. But for this question, question number 9, option A. Okay. Other student, please also try to give your answer. Amit, you can also take attempt. Okay. Abdul is telling also A. Good. Okay. Let me discuss. So here is, yes, option A is correct. Your tau is related with your pressure gradient, that is pressure gradient, oh yes, and R by 2. As you can see here, if just try to think, if this is Y is equal to the linear relation, this is this type of relation here, means linear variation, like that. If this is Y, this is X, so Y is equal to mx. So similar variation will be here also. So if this is R, so at R is equal to 0, tau at R is equal to 0, the value will be 0. So here let us assume at the center your shear stress will be 0. At the, if R is equal to tau at R is equal to small r is equal to capital R, if the total radius is R, so the value will be minus del P by del X R by 2, means maximum. So tau max will be up at your surface of the pipe. So this is tau max. Hope you got it. Now we'll move on the next question. Next question is, oh, before moving the next question, just I want to show you the slide, otherwise I'll forget. Let me just show you. Wait few minutes. Yes, now it is visible. So here you can just see the why we choose your circular pipe at the place of your rectangular duct and all. Just please, here it is very actually in the simplified way written. You have probably noticed that the most fluid, especially liquid, are transported in circular pipe. This is because pipe with a circular cross section can withstand large pressure. Remember, please, this is the point one. Large pressure difference. Withstand with large pressure difference your circular pipe between the inside and outside without undergoing significant distortion. Non-circular pipe are usually used in applications such as heating. Your non-circular pipe generally used in case such as heating and cooling system of building where the pressure difference is relatively small. The manufacturing and installation cost are lower and the available space is limited for ductwork. So here just about your the difference between your circular and your rectangular duct, or you can say the duct. But the why we, because the efficient flow, circular pipe offer a most efficient flow of fluid compared to other shape. The circular cross section minimize frictional losses and allow for a more streamlined flow. This result in less energy required to move the fluid and less pressure drop along the pipe, which is crucial for long distance transportation. Hope you got it. Very simple way I have written here. The uniform distribution. One point is this efficient flow. Another is uniform distribution. Circular pipe ensure a more uniform distribution of fluid. More uniform distribution. Everywhere distribution will be uniform of fluid across the cross section, and this help prevent uneven pressure gradient because everywhere the fluid is distribution is uniform, that's why your the it will be prevent the uneven pressure gradient and ensure that the fluid flow evenly throughout the pipe, reducing the risk of blockage of area or a stagnant flow. The another is structural integrity. The circular pipe have natural shape that distribute stress evenly around the perimeter. The stress distribution also good. This make them structurally stable and less prone to deform or collapse under pressure, especially when compared to other shape like rectangular or square pipe. So hope you got it. This was the major advantage we use the circular pipe in case of high pressurized flow. One is the it prevent the uneven pressure distribution, minimize frictional loss, and distributes stress evenly. So hope you all got it. Now we'll move with the questions. So here is the about what I was discussed previously. The your fully developed flow. Here you can just see. From here the velocity is varying, but here is linear. Here is that is constant velocity. Here is constant little bit, but after that your velocity is parabolic. So hope you all got it. And the reason is just you can see here the distance will be 0.07 re into d. That is the length of fully developed. So remember please. This is a laminar. This is about the laminar. If the water is flowing or fluid is flowing in the pipe with laminar flow, then you can use for fully development length is this much 0.7 re Reynolds number into d. Okay, so I think nothing is important here. You all know the Reynolds number, you all know that is average velocity d by mu. and here is hydraulic diameter. Just please see here, hydraulic diameter is dh by 4ac by p. 4ac here, in case of open channel you can write the weighted perimeter, weighted area by weighted perimeter. AC means area, the cross sectional area, and p is the weighted perimeter here. So remember please, for circular pipe your hydraulic diameter will be d for circular pipe. So actually your Reynolds number is, for circular pipe, your Reynolds number, if you write the formula for Reynolds number, rho V average and DH. DH means hydraulic diameter divided by your this mu, dynamic viscosity. So for circular pipe your DH will be D. For other shape, that is square duct, your DH will be A. For rectangular, your DH value will be this. For open channel, that is this, your DH value will be this. So remember please, always remember, for channel DH value will be this. So Reynolds number, the formula is, but circular pipe you can write D here because of the your DH value will be D. So that's why we generally write Reynolds number rho V D, but not D, hydraulic diameter. Always remember please, hydraulic diameter. Okay, now we'll move on the next question. Or not question. The another concept is, okay, this I have discussed, this is I have discussed. Okay. Okay, here we have lot of questions, but let us just solve for hydraulic engineering previous year questions. So let me just, I'll show you. So this is about the concept. Now I'll just share the previous year question. Okay. So here the question number 10. For turbulent you are telling 10D. Okay. Yes, actually for conceptual purpose I am following the Sinjal Simbala book. Yes, good. Okay, now we'll move on. Okay, for question number 10 you are telling. Let me just read question. So the question is, in laminar flow, the pressure drop per unit length of pipe del P by L is given by 32 mu U average D square. Similarly, option B, 2 mu U is U square, U average by D square, and here is 32 mu U average by D cube, none of the above. So please just try to give your answer for question number 10. In laminar flow, the pressure drop per unit length. Important one. Okay, you referred the Sinjal Simbala book. Okay, good. Sinjal Simbala book is actually very informative, so you can use. Or because of the very simple way all concept explained, and for more numerical point of view, if you want to see, you can go through the FM White book, but you just follow one book, not go here and there. That will be very difficult. Okay, So for question number 10, anyone want to give the answer for question number 10? In laminar flow, okay, A. Abdul is, Anurag is also telling A option. Okay. So actually I have not referred FM White book. Just I have read one or few chapters, one and two chapters. So actually actually for actually I am using this Single Simbala book because of the very elaborative and informative, or for you can say the pictorial representation is very well in case of your Single Simbala book. That's why I have more interest in Single Simbala than FM White. Okay, let me just discuss. Let me just show you the answer because this is just formula. So formula is this: del P delta Py 32 mu U average L divided by D square. So from here you can say the L will be this side and you can write this one. That is option A will be correct for question number 10. Now we'll move on the next question. Next question is question number 11. In case of laminar flow, the loss of pressure head is proportional to velocity square, velocity cube, none of the above. In case of laminar flow, the loss of pressure head is proportional to the loss of pressure head. A option, okay. You are telling B option, others is telling B, velocity square. Abdul is telling A, Anurag is also telling A, okay. In first question, actually, we were discuss about the major loss, that is your head loss. But here specifically ask question is asking about pressure head. In first question, we were discussing about the head loss, but here is specifically the pressure head. So just think on that. Okay. So everyone telling A, yes, A option will be correct because just from here you can see. Okay, now we'll move on question number 12. The laminar flow is characterized by existence of eddies, irregular motion of fluid particle moving in layer parallel to boundary surface. And D option, none of the above. So everyone please, this is a basic and fundamental question. Okay. C, everyone telling C. Yes, option C is correct for question number 12. Let me just show you the another question. Okay, this one. Yes. Yeah, question is visible. The question is visible, please. Just confirm. New questions. Yes or no? Yes, just you can write. The question one, which among the following does not? Okay, good. So just please try to write your answer. Abdul is telling A for question number one. So let me just read. Which among the following does not depend on friction factor, pipe diameter, fluid density, viscosity, weight? Okay, everyone telling A. So let me just discuss for maybe another students which maybe I have not joined. So as we have discussed the first question in uh, previous assignment questions. So your head loss FLV square by 2Z D, diameter of pipe capital D. So pipe diameter, fluid density and viscosity, no. Which among the following does not depend on the friction factor? Here we are talking about the friction factor, not your head loss. So friction factor, let us assume that for laminar flow 64 by Re, and Re is equal to, as you all know, average, and in case of pipe your D value and mu. So from here your F is equal to mu 64 rho U average D. So as you can see here, your friction factor depend on mu, viscosity, density and diameter. So only weight but not depend on weight. Okay, let me just go with the next question. Question number, oh, here you can just see the answer, but let me just discuss. Question number 2, the total head loss for a system is equal to pipe length, pipe diameter and the width of reservoir and the height difference of reservoir. So as you will apply the Bernoulli equation between to your reservoir case like that, here is the whatever the head loss will be, so that the height difference you will show you the total head loss in the system. Okay, the next question, let us move. Here just you can read detailed solution. The total head loss for a system is equal to height difference of the reservoir, and the height difference is denoted by letter. Okay, this is not given. So this is not a standard notation. So total head loss can be equated by summing it up with all the local losses and the losses at each pipe. Okay. So as you have solved, when you will go through your previous year questions, get previous year question, you will get lot of question based on this concept. Okay. So question number 3 is, which of the following is major loss? Friction loss, shock loss, entry loss, exit loss. Major loss here I am talking about. The question is talking about major loss. Okay. Abdul telling A and others is telling A and Anurag also telling A. So question number 3, the you are telling the major loss is friction loss, and the formula what we are discussed previously. Actually, we were discussed lot about this formula today. FLV square by 2ZD. So this is the this loss, the formula for due to the friction loss is this. So this is the major loss formula. Darcy's Weisbach equation. Next question. Detailed solution. The major loss for flow through a pipe is due to the frictional resistance between adjacent fluid layer sliding over each other, and all other losses are considered the minor losses. Whatever the losses is here, the minor losses, and the frictional resistance between adjacent fluid layer. Just imagine there is a pipe and one fluid layer is flowing here, another, let me just draw whole length, another is the here, another is 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 here. So this is one, this is also one, this is two. Let me just write in different way. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Just assume here 4 is in mid. So just I want to write here V1, V2, V3, V4, V5, V6, V7. So V1 and V7 is this one, or V1 is equal to V7. Which option will be correct if this is A and this is V? Just please tell me, then I'll just tell you one concept here. Okay, so you are telling B. Okay, everyone telling, Anurag is also telling B, others also telling B. B option is correct because both are just near to your uh, surface. Similarly, you sorry. Similarly here your V2, V6 will be equal, V3, V5 will be equal, like that. But just remember please, the V1 will be less than V1, or V7 is less than V2, or V1, or here also I want to write V6, or V7 is greater than V2 or V6. This is option A and this is B. Which one will be correct? Let me just write in this way. Okay, which option will be correct? Okay, so Abdul is telling A option. Okay, Anurag is also telling A. Okay, AQ. AQ means what? Okay, A. Okay, so here is, just try to understand, due to your this the friction due to your the no slip condition, your v1 and v7 will be same, but just above the v1 your velocity will be high, that is v2 will be high than v1 or v6 will be high than v7. So this is clear to all of you. Now here is just try to understand, if something is moving in this direction, then what will happen? This layer will try to reduce the velocity of this layer, and this layer try to reduce the velocity of this layer similarly from these directions. So what will happen? The each layer try to reduce the velocity from surface to the adjacent layer. So that thing only here written. The resistance means just try to reduce the velocity. So, and these things contribute in major losses, that is the friction losses in the pipe flow. So this is all about your concept. Now we'll move on the next question. Okay, here just you can see the answer will be B. The question number 4, for laminar flow in pipe the momentum correction factor is, let me just momentum correction factor I want to write with the momentum correction factor in case of laminar and momentum correction factor in case of turbulent. So which one will be correct? This is A option, turbulent, and B option is, which option will be correct? Here the option is B is correct for this laminar flow in pipe. The momentum correction factor is 1.33. If the flow is turbulent, then what the value of momentum correction factor? The value of momentum correction factor in case of laminar is 1.33. But in case of turbulent, you just try to just write your answer in the chat box and whether option A and option B will be correct. Let me just see your answer. Okay. Kinetic energy correction factor you are telling 2. Okay. In case of laminar, so anyone just want to tell? Then I'll just show you the answer. So just think on that. The momentum correction means what? The correction due to momentum. Momentum means what? Mass into velocity. Means momentum transfer. Here something is talking about momentum transfer. In which case momentum transfer will be more, whether in turbulent, whether in laminar. If the momentum transfer, others is telling momentum transfer will be more in case of turbulent flow, that is the zigzag motion and turbulent flow laden with your eddies. So definitely momentum transfer will be more. So based on this, if the momentum transfer is more, definitely your momentum correction factor should be more or minimum. Just think on that. Just I have given you a hint. Now just please try to give your answer, everyone please. If the momentum transfer is more in case of turbulent than laminar, So which option? Okay, B you are telling, Anurag is telling B. Momentum correction factor will be more in case of turbulent than laminar. Okay. Yes, so just here you can read the detailed solution. Momentum correction factor is defined as the ratio of momentum of flow per second based on actual velocity to the momentum of flow per second based on average across the section. Here just see. For turbulent flow, the momentum correction factor slightly higher. That for turbulent flow, the momentum correction factor is slightly higher than 1, rear to 1.2, and for laminar its value is 1.33. So if you will see here, the momentum correction factor is slightly higher than 1 means what? If beta, if I write here, the beta value will be 1.2 for turbulent, and beta value for your laminar is 1.33, means option A will be correct. The momentum correction factor is in case of laminar will be more compared to this. Why? Just I want to tell you. Here is momentum, as you know this formula, the velocity distribution in case of your, because it depend on velocity. Just I was telling about the basic fundamental is momentum is mass into velocity, depend on velocity, right? So this is your parabolic diagram. In case of laminar, if you will see, in case of turbulent, the diagram is like that, parabolic. Here is the logarithmic. So when you will average this value, when you will average this value, and when you will average this value, so the average value will be here and here. The average value will be less here when you will average, because the parabolic variation. Here almost whatever the maximum velocity, when you will, let us assume here the maximum, and you average. Here also you maximum and you average. So here maximum is much more than average, but here maximum is little bit more than average, because the here if you will see, the diagram is almost the flat compared to this laminar. So that's why if the average velocity is little bit more than maximum, so when you will divide something with, just you can see here the division with average velocity to your actual velocity, so definitely in case of turbulent your value will be less. So this is all about your momentum correction factor. The next question is, which property of the fluid account for the major loss in pipe? Density, specific gravity, viscosity, compressibility. Which option will be correct? So hope you got it. How in turbulent will be less. Ahmed is telling C, viscosity. Okay. Others is also telling C. Okay, everyone telling option C will be correct. Yes, definitely C will be correct. Next question. So here option C will be correct for question number 5. Next question is question number 6. Here you can see the answer. B will be correct. Let me just read and discuss. if the flow rate of water in pipeline is double, then the pressure drop will be whether the same as original value, whether the 2 times of original value, 4 times of original value, and 1/2 of the original value. Definitely your 2 times of the original value. If the flow rate of water in the pipeline double, means initially your discharge was Q, and Q2 will be, in the second case is given, if the double means 2Q, then the pressure drop, that is P1 minus P2, value of P1 minus P2. So just you can think using this, what we were discussing previously, these things. Here you can see. So from here you can just write delta P is equal to directly proportional to your velocity, or you can write with, if the area is constant in both cases, so you can write here your delta P is equal to, as you know, the velocity is equal to Q by A. So Q is directly proportional to your Q. So velocity is this. So at the place of velocity you can write Q also, Q, right? So here delta P divided by delta P2, it will be your Q1 divided by Q2. So here is Q and 2Q, means 1 by 2 delta P1 delta P2 from the original value, means your P2 will be, delta P2 will be 2 times of your original value. Delta P2 will be 2 times of your original value. Original means initial one. So hope you got it. Now the next question is, okay, the question number 7. A liquid flow through a pipe 1 and 2 with the same flow velocity. If the ratio of their pipe diameter D1 is to D2, 3 by 2 or 3 is to 2, what will be the ratio of head loss in two pipes? In the similar manner, you just think and try to, just similar the previous manner, try to give your answer for question number 7. A liquid flow through, okay, inverse, you are telling option C. Other student, please also try. Okay, Abdul is telling also C option. Okay, good. Anyone want to tell? Yes, definitely it will be C, but how? Let me just explain. Others is telling, yeah, just inverse, but how inverse? FLV square by 2ZD. The HL is inversely proportional to your D, or you can write a small d also, as D1 D2 is given. So means HL1 is equal to 1 by D1, HL2 is equal to 1 by D2. As you just write in the ratio form, HL1 HL2, that is 1 by D1 divided by 1 by D2, means D2 by D1. So head loss just here is HL1 divided by HL2 is equal to D2 D1, means 2 by 3. As you here know, the D1 by D2 is given 3 by 2. So D2 will be 3 and D1 will be 1. So that's why D2 is 2 by 3. Hope you got it. Option C will be correct. Now the next question. Question number 8. Water flow through a circular tube with velocity 4 meter per second. The diameter of the pipe is 15 centimeter. Take kinematic viscosity of water 10 raised to minus 6 meter square per second and density of water is 1000 kg per meter cube. So here you need to calculate the Reynolds number. Question number 8. Everyone please. Question number 8. Here you need to find the Reynolds number. I think in question not mentioned, but here you need to find out the Reynolds number. Which option will be correct for question number 8? Velocity is given, diameter is given, and kinematic viscosity is also given, and density of water is also given. Okay, D you are telling 6 into 10 raised to 5. Okay, whether it is laminar and turbulent. Also, everyone please tell whether the flow is laminar or turbulent. Okay, Abdul is telling turbulent. Okay, so how you will calculate? Let me just show you. For maybe who had not joined today, so maybe anyone have confusion, so that's why I'm telling. Re is equal to rho V d divided by mu. So as you all know, the kinematic viscosity is given, you know already. The kinematic viscosity is dynamic viscosity. The viscosity will be in nominator, remember please, and rho. Sometimes maybe you have confused whether it is denominator or numerator. Dynamic viscosity, it will be nominator, denominator, because here is the viscosity, here also viscosity you have to maintain. Okay, now so your formula will be average velocity, this is average, and diameter of the pipe, and here kinematic viscosity. Now you have to put the values. So 4 into 15 centimeter means 15 into 10 to the power minus 2 in meter divided by 10 to the power minus 6. So 60 into 10 to the power minus 2 into 10 to the power 6 means 6 into 10 to the power 5. That is option D. And if this is pipe flow, and the value is greater than 2000, that means the flow is turbulent. Okay, here our question is, when a problem states the velocity of water flow in pipe is 20 meter per second, which of the following velocity is talking about? RMS velocity, average velocity, absolute velocity, or relative velocity? Just please try to give your answer. If just simply one question is telling about or talking about the velocity of water, whether it is RMS, average, absolute, relative. Okay. Others is telling B option. Okay, good. Other student, please also. Yeah, definitely it is average velocity. Remember, please always. If not written average velocity, just assume the velocity, given velocity is average. Here is explained very well. In pipe flow, the velocity is always referred as to the average velocity. There may be case where water particle move in the same direction with 20 meter per second, then the average velocity will be equal to absolute velocity. But this is only a special case, since the average velocity will always be true. So this is just explanation little bit. Now the next question is question number 10. Which among the following formula of friction factor of circular pipe? So remember, here is talking about the flow condition is laminar. The flow condition is laminar for this question. Now you just try to give your answer. The friction factor for question number 10. Okay, others is telling B. Abdul is telling A, B. Both you are telling? Okay, only B. Yeah, definitely it will be B because we have discussed lot. Amit is telling 10D means what? Okay. Others is telling for turbulent smooth flow, the value will be, that is your formula of friction factor will be 0.316. Are you okay? So option B will be correct for laminar flow, circular pipe, or any laminar flow, not specifically I'm talking about circular. Let me just move on. Next question. The hydraulic mean depth. The hydraulic mean depth for a circular pipe of diameter 100 mm when running full. So here you need to calculate hydraulic mean depth. Hydraulic mean depth. Which option will be correct? D by 4. Okay. But what should be the value? Okay, bit confused. Okay. Let me just show you. Here talking about hydraulic mean depth. So hydraulic mean depth is A by P. Remember please, hydraulic mean depth or hydraulic radius is same. So D by 4. 4 means you are talking when the talking about diameter. Then you go for hydraulic mean diameter, then you can go for this formula. But here just remember, for diameter you need to this apply this one. Otherwise you can apply this. Now the next question is, so definitely D by 4 means 100 by 4, that is running full. Running full means your depth of the flow will be 100 mm. So hydraulic mean depth D by 4, that is R is equal to A by P, pi by pi R square divided by pi R. So 2 pi R. So pi pi will be cancel out. So R by 2. R by 2 means if the diameter is 100, so it is 50 R, that is radius, and by 2 that is 25. So your answer you can see 25 mm. Now the next question, in turbulent flow in a pipe of friction factor is 0.04, estimate the ratio of shear velocity. Shear velocity U star to the mean velocity U average. That is ratio you need to calculate. Here you need to calculate the ratio. If the friction factor is given 0.045. Everyone please, this is the last question for today's session. Actually these are the question based on your this open channel hydraulics. I think some whatever the formula here is used, so just think on that. Why you cannot use A by P in case of this hydraulic radius? I think the formula should be same everywhere, or maybe terminology will be different for another formula. So just please try to give the answer for question number 12. One formula also you remember please, hydraulic uh, here is mean, talking about mean, but hydraulic depth, that is A by top width. Remember this one also. Sometimes in case of root number, generally in civil engineering we use, that is V by root GD. D means here A by T, hydraulic depth. Area by top width. Okay. So for question number 12, let me just show you the answer. So here formula is this one. u star by u average is f by 8. So by using you can calculate, the answer will be 0.75075. So option C will be correct for question number 12. So hope you all enjoy for today's session. So we'll meet again on the next Friday. So thank you for today. Okay, thank you all. So now everyone can leave the class. Okay, thank you.